with a brief preface of I expect this or hope for this to be pretty conversational, definitely don't hesitate to interject, ask a question, ask for clarification. Um, my topic, I'm going to present on the research I'm hoping to do in the PhD, which I'm just on the cusp of starting. And so I'll try to keep it high level, but this is also a somewhat deep dive by the nature of it, just because I've spent entirely too many years in the world of civil and environmental engineering, probably forget exactly which concepts or words are difficult to grasp for someone who has not understood or studied this industry. So I'll try to keep it approachable and interesting. I think there are inevitably a lot of parallels to be drawn with other industries, regardless of your professional focus or interest, but definitely don't hesitate to ask any clarifying questions if I go by things too quickly. So the general high-level overview of the topic is called industrialized construction, and then my particular interest in that is in civic engagement. So I'll start by just addressing what are the problems in the industry of construction and architecture and engineering that have led to this demand. But first off, just what my actual background is mostly in civil and environmental engineering. I think I've long been driven by the idea that the built environment can do more to address the challenges presented by climate change. And when I was choosing between engineering topics to study in my first degree, only one of them had the word environment in it. And that was pretty much the full logic behind the choice. So got 2 degrees in civil and environmental engineering before I discovered urban planning as a field and profession. And for me, that was really taking the interesting potential of buildings at the individual project scale and going one level up to the urban scale. So not just how you can improve environmental outcomes with one building, but how do you organize buildings across an entire city to achieve these broader outcomes. And then you also have to incorporate broader social goals like addressing homelessness and affordable housing things, which were topics I cared about a lot and didn't know how to address in the project-specific engineering level. And so instantly fell in love with urban planning and have been pursuing that for the last few years, mostly through urban planning nonprofits that do a lot of advocacy work. And the general theme behind the work was helping city level decision makers make more evidence-driven choices and policies. So a really basic example is historically a map that determines which neighborhoods or communities are most vulnerable to flooding, especially with sea level rise, is developed by extremely technical, intellectual, talented experts, and then provided to a city decision maker on its own. And it's not overlaid with, for example, what parts of the neighborhood or community are the most vulnerable to flood hazards. So that could be the neighborhoods that are the oldest or have the most elderly there. It could be the lowest income and the least able to take the financial stress of not being able to get to work because the street is flooded. And then that map would not be overlaid with something like the transportation map, which might just show where the bus stops are and how common or how used they are. And so historically, these talented experts in urban planning would develop all these maps independently. And a lot of the work I've done and will continue to do is just overlaying these maps in one interface, which is very simple to do. And I'm thankful to not need to know a lot about each of the individual silos to do this. But having that information presented in one graphic or one platform is huge for, say, a mayor or governor or city council member, really amateurs in terms of data science, not for bad reasons, but who don't know the mechanics and the math behind each of those individual maps. It allows them to see that information in one platform and make more informed decisions around how the city will grow or develop over time. So my bend really is combining existing disparate or independent fields and overlaying all of the incredibly detailed work and knowledge that has been accrued in a way that normal humans can understand and make decisions based off of. So with that framing, the path I've gone within the construction field will make a lot of sense. So if you don't know much about design and construction, the basic summary that most presentations start with is the productivity of the construction industry is comically behind. It has gone more or less unchanged in the last 150 years. And there's many versions of this exact graph, but the major point is that almost every other industry, agricultural, manufacturing, anything you could think of, has seen huge, unsurprisingly huge gains in productivity over the last 50 to 100 years. In construction, we do more or less the same way and with the same inefficiencies as we have for a long time. Obviously, that's problematic, even though there are plenty of good reasons for it, like we've raised standards for buildings over time to match any gains in productivity that we might have had otherwise. But nonetheless, it's still concerning that we spend more on buildings now per square foot or per square meter than we have in the past, rather than less. Another huge component of this, also probably unsurprising, is that almost every other industry, as part of the process to get more productive and carry over the knowledge from achievement and projects forward and improve upon that over time, construction just doesn't use a lot of data. It produces a ton, like even the labor productivity. Every single project will have, to the utmost detail, the amount of work done per laborer in every single section of the building, in every trade. And yet we don't actually, there's no platform to publish that through. There's no collection of that information or optimization of that process that gets carried on into the next project. It's pretty much just embedded in the humans that do the work. So construction managers or laborers themselves. And though there's value to that, you get an expert in a field with this deeply embedded knowledge, you also don't get a lot of the industry-wide improvement that you could if this knowledge were uploaded to the cloud, so to speak. And so there's that's a critical barrier to this introduction of construction world into the digital age, is just that they've actively not participated in the digitalization of tools and information that most other industries have clearly benefited from. So with that, I introduced the idea of industrialized construction, which is one, but also one of the most popular ways in which the built environment industry has tried to meet the shortcomings that I just described. Try to raise the productivity substantially, try to increase reliability of the construction world, try to make use, and make use of all the digital information that we could be getting from our buildings. And so the general idea is to change the process of design and construction in such a way that allows it to benefit from the industrialization of the world that has been happening for the last 150 years or so. There's many ways to do this. The most basic analogy is trying to make buildings more like we make cars. And so you'll see in the photo, in a factory setting, controlled environment, there's a roof, much easier to organize labor, reduce physical strain, reduce the verticality of a given project. You make these full blocks of units, and then on site, as you'll see on the right, you can just stack them into place. It can get more complicated than this, but that's a general idea.
Tyler, can you hear me, Tyler?
Yep.
Is what you're saying effectively that the construction so far has been a bunch of people coming up with something which hasn't been done before? It's starting from scratch each time without any knowledge of what works or what doesn't work. And then when they've finished it, they move on to the next one without looking back and seeing, well, actually, what does work and what doesn't work. And so how can we learn from this experience? And so we have iteration 1, 2, 3, 4, 5. Is that, so instead of it being a series of one-offs and prototypes, you're saying let's make it into some sort of organized system?
Yeah, The common phrasing is that every building is a prototype,
Yeah.
is how we've done it historically.
Yeah. Got
And
it.
that could be just because the laborer and the construction manager that organizes the labor on one project really only becomes an expert in that architect's detailing. That could be the format that they put the drawings of the building in. It could be the software that they use to do the 3D model that they may or may not use to inform the construction. But as soon as they go to another project, it's a different architect, possibly different software, different style or design approach. And so they're learning from scratch every single time they start a new project.
Yeah.
And to be fair, projects can go like at the very least 1 to 2 years, which is already long, but a lot of projects go 5 to 10 or even more years. And so the natural cycle of staff turnover and even just human memory is very hard to match the lifespan of a typical building project. So even if they did perfectly embody the knowledge that they gain on one project, they might only have 5, 6 projects in an entire career before they retire. And that's very difficult timescale over which to rely on humans alone to carry on and embody this knowledge that they gain on every project. So yeah, your summary is a good one. And that's one of the limitations and challenges that industrialized construction tries to overcome, is changing that every project is a prototype paradigm into the process is the thing to get knowledge about. And that ends up being the medium through which this knowledge is carried from project to project. So that instead of on the right here, that being a one-off project, like they only know how to do the modules on this one project, the version of the left is that creation process becomes the project that you could spend an entire career on continuously and improve that process. And it's project agnostic. So you don't need to know the site details or the specific architect to be able to do that factory production of a unit without, you can do that without needing to cater it to every specific architect style or a software or whatever it is. And that's a huge change. It sounds very simple, but for construction, that's a massive change, as I'll go into a little bit later. And there are other versions of this too. So the one I just described is the simplest analogy in terms of building entire apartment buildings by block. But there's iterations or levels of this you could do. So one other analogy is the IKEA system, where instead of building entire units, you could build the unit in terms of its individual walls and then stack the walls without connecting them yet on a back of a truck so that it takes up less space. And then once you get to the site, you place them together or assemble them in a much more simplified and hopefully faster way than you would on a typical site construction, which the example here, instead of having this wall that's pre-assembled, you'd have to be manually cutting out every hole for every window, getting the glass in separately, installing the windows separately. So really just trying to reduce the number of variables depended on site. And then one of the more advanced and interesting applications is one level lower. So instead of these big volume units, instead of the flat pack, a kit of parts solution, basically like Legos, where if you can simplify the building before you start construction into a lot of pre-designed and easily assemblable components that get shipped to the site and assembled with relatively easy directions. Again, it's an attempt to simplify the design and construction process to save time, save money ideally, and hopefully you're able to keep those individual components the same from project to project. So you could change the configuration, make wildly different buildings in different shapes, but if you can break it down to a certain number of components that can stay the same, you're still getting a lot of benefit from keeping that knowledge embedded in the process from project to project instead of starting from scratch every time. So a the interesting outcome of this really is it's a reframing of how to do and deliver buildings. Uh, Inevitably, any project, whether it's industrialized construction or not, is an attempt to combine four, and you could reframe it however you want, but in this case, four major views or ways to look at a building. So at the very basic level, and typically the most complicated, there's the engineering view, where you have engineers come in, confirm that the building conforms to building code, make sure it can resist earthquakes, and a lot of other very technical details that I, as a person who lives in an apartment, don't really care about. I hope that it's done well, but I don't need to know or understand the engineering components within a building. Then the site view typically is the part that an architect cares about or focuses on. How does it look from the outside? How does it fit together within the rest of the urban landscape? How do the components fit together, making sure there's room for things like plumbing and air conditioning and heating systems? Slightly less detailed than the engineering view, definitely more detailed than my view as an apartment resident. And then the customer, pretty apparent, is what's the experience living in the building? How do you see it from the outside, but also how do you use it? How do you actually exist within that building? And then the additional view that industrialized construction brings is that production view. So too soon. Really, how do all of those meld into creating the building? And historically, the production view is pieced together after the fact by the people working on site, and it's typically very complicated. Buildings take a long time to build. They are often hard to estimate in terms of how much they will cost, and typically they end up costing more than people expect because the first three views are created by an architect and engineer, and then the site laborers or construction managers are left to figure out how to actually create that physical space. Industrialized construction has the convenience of building the production view into that factory setting. So the constraints of construction are known, the abilities of what can be created in a factory are known, and the details of how long it will take and how much it will cost tend to be more predictable. So a huge advantage of this is that industrialized construction allows that transfer of information through each of the sections or the views without friction. It is no longer this transfer on the right here. It's no longer the project owner talking to the construction manager, talking to the architect, bringing in the engineer, bringing in the construction manager, and all of those being different companies. Instead, you're trying to embed all of this knowledge into different layers of the same file, for example, where you click a tab and the exact same project you're looking at is just shown a different view of it. It is shown the customer view, that's the prettiest version, but a few clicks later, with all of the same information but more detail, you could see that production or the engineering view. And so everyone's speaking the same language, basically. This requires, unsurprisingly, a lot more thought put up front in a project. These people need to have the conversations to determine the information behind these layers, but it all comes before the project is actually being built. And so hopefully you avoid a lot of the complicated legal procedures later on of, you drew up this thing that we can't physically build, and we're going to build it, but it's going to cost more than you said it would. And later on, we're going to sue you to see who actually ends up having to pay for that. What this does, having all the layers in the same file, so to speak, just avoids that complication or conflict later on. And that's one of the foundational ways in which industrialized construction kind of brings the decision-making to the front or the beginning of a project before you run into problems. Another way of putting it, and I think this is the more business level way, and I like it for that reason, is historically building has been a service. You as a designer, architect, or as a construction manager offer your service of designing a building or building a building, And all of the details, as we said earlier, are determined from scratch, from project to project. And so any project owner or developer comes up with this weird shaped building and says, figure out how to create this. And the job that you're getting paid to do as a laborer is figure out how to bring that two-dimensional drawing of a building, or maybe three-dimensional drawing, and create it in the physical space. And you get to figure out what material it uses and a bunch of other things. And your service, your job, what you get paid to do is manage and negotiate that process. As you increase, so to speak, the level of industrialized construction, the reframing starts to be the opposite, where you as a construction manager or an architect create a product, and you don't have a particular site in mind or a particular project in mind, but you have a process or a product in mind. Maybe it is an extremely well-designed studio or one-bedroom apartment that includes the details of how you're going to build it in the factory. Internally, you know, no matter what site that it will be placed on, you know the price and the time it might take, the laborers it will require, and you have all of these things predetermined by your product. And then you go outwardly facing, you find a developer or a project owner and say, hey, I see you have this land. Let's make this pitch to you, show you what a building we can build. We know how much it costs. Let's show you what it looks like. And that's totally changing the stakeholder relationship. You get to pre-decide a lot of the things you want to focus on as a designer or a builder, and you end up coming towards the bottom section of this graphic with a standardized product that you can pitch to a variety of sites or places in the city or across a country or around the world. And the dynamic of that is completely changed. The mentality of it has changed. The building proposition or the business proposition is totally changed. So you can have a set price. It's not as competitive or antagonistic as it is historically, because you know the constraints of your system. You only approach projects that your building is feasible on, and you're not trying to negotiate after doing construction who is responsible for what cost. A lot of that stuff is just avoided from the get-go. And so again, I can't understate that this potentially is a complete reframing of how people approach doing buildings. It's not always for the better. I can get to weaknesses later, but it is just fundamentally different than how we've done it in the past. A huge part of why this has taken so long to do and why it hasn't been done as much, with a huge exception of the fact that the US is only recently adopting this in major form. A lot of Western Europe and a lot of Southeastern Asia has done this successfully for decades. Naturally, in the US, we're far behind and we consider ourselves original. But that being said, within the sphere of the construction world, a huge limitation to try something so fundamentally different is that we are constantly operating on very small margins, and historically spend almost no money proportionally on research and development. There is very little wiggle room to invest in these wildly different, innovative approaches to doing design and construction. Even if it's just investing time and effort into doing a software tool that might make design easier, the 0.5% of annual revenue invested in R&D just makes it really difficult to take risks. And so one of the major reasons in the US this is coming about so quickly is that there's been an enormous interest from the startup world, enormous amount of venture capital invested in the last 5 to 10 years in ventures that do industrialized construction. And there's probably plenty of background reasons for this. Basic ones like housing costs have continued to soar, so there's been higher and higher demand to save costs on construction. Cost of labor in the US especially has continued to rise. And so with less labor and higher cost of labor, there's a lot more incentive to save and improve productivity of this field. And we've just started to reach a breaking point where venture capital has realized the potential. But regardless, the point is, this amount of startup funding in such a historically traditionalist industry, construction and design, is unprecedented. And the fact that they're mostly focusing on industrialized construction ventures, I think, is a huge signal that this isn't a passing trend. And regardless of which companies will fail or succeed, I think the overall theme of doing industrialized construction is here to stay. And one of the most fascinating things for me to have found is that the companies starting to adopt this, let alone just startups, are coming from a huge variety of perspectives. With my introduction point being that the stakeholder relationships are really fragmented and difficult to overcome from project to project because you're changing partners every single time. It's very interesting that every stakeholder imagined in a typical construction project see different value in adopting industrialized construction. And so there's a lot of very interesting questions just around this graphic of what are the differences in the methods or strategies or priorities of, say, an architect doing industrialized construction versus a real estate developer or a general contractor doing it. I'm sure there are very interesting answers. That research has not been done yet. Maybe I'll do it eventually. But regardless, it's promising that multiple avenues of professionals within the building industry see value in this new emerging trend in the US. And another huge part, just to validate what I said earlier, is that by necessity, basically, because you have to bring so much of the decision making up front to do industrialized construction successfully, there's a huge amount of integration required, which, yes, does require more effort and thought up front, which is a barrier, but also makes it easier to embed that knowledge in the process or the company or the platform, whatever it is, rather than rely on individuals who work on each project. So the summary here, the detail of horizontal integration and vertical integration. Horizontal integration is really just the building trades involved in the construction process. So everything from doing the foundation to building the structural framing to doing the plumbing and heating services within the building to doing the facade or the outside, the beautiful external part of the building. More and more companies are taking all of those and putting them under the same roof, quite literally, and not relying on individual contractors to do each separate step and trying to organize that logistically. And the vertical integration is really the long form. What part of the building delivery process do they handle? So that starts with the real estate development, the purchasing of the land, and the ideation of what can go there and what gets built there, the design aspect. So bringing in an architecture and saying, what does the shape of the building look like and what will be inside, along with the construction, actual physical delivery of the building, and then the maintenance and operation downstream. So after people move into the building, managing the repairing of any necessary components, but also a more recent one is managing the energy usage and making sure people are using the energy as efficiently as possible. All of these things, again, typically done by different stakeholders on any given project, but a lot of the companies adopting IC tend to bring this in-house so that the incentives of making the building perform with high energy efficiency are thought of in the first phase of buying land and considering what can be built there, which is an alignment of incentives that has not really existed in the past. A real estate developer purchases the land and designs the building without thought of energy efficiency unless it makes them money up front. If you're integrated, if you're going to be the same entity managing the building after it's built and occupied, then suddenly you have a direct incentive to not design it to be energy efficient only, but to also make sure it delivers on that promise, to make sure people, the occupants, are using it as intended, even after it's occupied and it's 30 years down the road. And so the delivery on performance promises in the beginning phases of a building is also being under one house makes them align and hopefully deliver better buildings in the end. So one of the more exciting aspects of this for me is basically democratizing the process behind buildings. In terms of going upstream, approaching the professional end of this field, you can simplify a lot of the more boring and frankly annoying things of doing design and construction. So one easy and emerging example is automating the design. And here it's a bit hard to see because I took a screenshot as an image, so it wasn't very high quality. But imagine basically getting a physical site that you're about to purchase the land on, no building on it, but you're just wondering what can be built there. And in a tool like this, for example, you can say exactly how tall you want the building, how many floors you want, potentially how many units you want, or what types of units you want. So for example, in housing, you could say you want 80% to be 2-bedroom units. You want to house young couples with 1 kid or something. And real estate developers will go in with this exact plan and mentality. So this isn't different than how it's done already. But imagine just typing those things in and having the shape of a building proposed immediately. It's very rough. It's not beautiful, but you'll have an initial idea both of how it would look, how it would fit into the rest of the urban landscape, but also potentially attach costs to this. Maybe as you type this in and say you want, X number of units, and it does this very initial prototype design, it is actually linked with a company that does the production of those units. And based on historical data, this software tool might give them direct information saying, on average, the units you described or desire cost $200,000 per unit. And a project that we built using that production platform, that was 3 blocks away from the site you're looking at, cost this much money to do other work like site work or foundation or utilities work. And suddenly you'll have a reasonable estimate without having to get a professional involved yet of how much this building might cost, theoretically, what it might look like, and play around with those numbers until you at least get something promising enough to move forward. Maybe that does mean you purchase the land. Maybe it means you have more details when you go to this manufacturer and say, hey, we used your design tool. Complete amateurs. We are not architects, but we used your design tool and like the look and shape of the building we designed. Let's talk more about how do we make this more beautiful? How do we include maybe a park, a dog park in the center, something like that. And suddenly the conversation has progressed way faster and with way less time needed to deliberate between professionals. And I think that's huge, personally. And then the opposite direction, so not approaching the professional stream of simplifying design to the extent that I just showed, but going the opposite direction, going towards how amateur can we get with who does design or who is involved in design. And I think it's pretty easy to imagine, I even got into it a little bit in the last slide, of someone who doesn't know anything about building design, especially not engineering or earthquake proofing a building, giving their ideas directly to inform the ultimate delivery of a building. It could be how buildings are organized together. It could be the shape of the building or the amenities included. But there are already examples, especially in the UK, thank you, Marcus, of companies literally using students, school-age children, to use the software tools I described and gave examples of to give their own ideas as to what their school can have. And the architects, 40-something professionally talented, extremely intelligent architects, could never come up with the ideas that the students would for basic ideas or design principles of what shape is most conducive to their learning. The architects might know things like how to make sure the temperature of the room is ideal at all times for energy efficiency purposes. They might know, according to the building code, how much daylight every room should have to make sure the kids can see outside. And that leads to, more focus in the classroom. And these things are definitely important, but it would be hard to argue against the value of having the students or other occupants of a building give direct input to the architect. Even an extremely arrogant architect would admit that the users of the building would come up with more ideas than they possibly could. And so not only does it involve these amateurs who will eventually use the building early on before the building exists, but it improves the building. The architects are at no loss. They are still talented professionals that will need to bring this building into existence, but they get more ideas and can filter through more creative applications of the building they're eventually going to build. And so I see endless potential value to the buildings themselves, the profession as a whole, but also the community at large. Like the people who will use this building, I think it's safe to say, will feel more empowered and involved if the ideas they input in an early conceptual phase process of a building get actually delivered to the site that used to be an empty lot a few years ago. And now they're using that space and they can say, this shape of this room was my idea and this is freaking cool, basically. And so that is touching the surface of the potential of this thing. But for me, that is a critical piece of the focus, is just how to use this emerging trend that does focus on saving cost and saving money and simplifying the process for a lot of very business financial reasons, and figuring out how to use those trends to bring more people into the process. And so just an example to really bring that point home, this is the skyline of Seattle in about 2017. I think this picture was taken or model was given. Just during 2017, the buildings in Yale are ones that are planned, so probably going to be approved, but at least have project owners who have proposed the building, the size shown. And then red, both the light red and the dark red, are projects that have already been approved and possibly already started construction. And that's just from 2017 for the next 10 years. So the major point is, by necessity, our urban environment is changing immensely, constantly. We often don't even know how it's changing or how much it's changing, and certainly don't usually have direct input into how it's changing. At best, we might have a public meeting when any one of these buildings goes up for approval, where we can show up, give our opinion on the drawings that the architect made, and usually it's people just saying, no, we don't want that building to exist here. But to me, the promise of industrialized construction, or the extreme optimism of industrialized construction, is that process, that engagement between the resident or community or the ultimate user of a building and the professionals that bring it into existence, can be so much more detailed and interesting and ideative in terms of people creating new ideas for it and imagining ways we can use and deliver buildings that the professionals alone just can't come up with, by virtue of being too deep in their own heads and being too tied to purely financial constraints. So to me, the changing of the paradigm of how we do building is a way to make sure every one of the buildings in this image is improved upon by amateur input, by our input, and hopefully delivered more cheaply in the process, but ultimately just serving more purpose for the cities that they're built in. And that is driven very much by youthful optimism, but nonetheless, that's the facade I'm hoping to uncover in the research I do over the next 5 or so years, and probably beyond. So if any of that made sense, or if it didn't, I'm happy to answer questions, table discussion, talk now or offline, if anything comes up later. But hopefully that was at least interesting.
That was really good.
Thank you so much, Tyler. That was a great presentation. This is kind of the first time I feel like I hope the next speaker runs late so we can have a longer conversation while you're talking. I have one quick question. Basically, what you're doing is you're democratizing architecture, right? Everyone can
Hopefully
be an architect. And
yeah.
You're bringing ICT, you're bringing information technology, you're bringing digital mindset into the architecture. But wouldn't it be a logical next step that every building would actually be a data company of its own? That not only the construction is digital, but actually the building itself is also a source for data mining and better understanding the environment and delivering information that's valuable for, I don't know, utilities or wherever, municipalities.
Absolutely. So actually I'll try to reshare screen, because like an amateur, I ended prematurely not thinking I would go back to certain slides. But one of the more long-term hopes, I think, in this view in particular, is that the actual use of the building, how it's used, both like how people get around within the building, which rooms tend to be most used, but also, as you said, how much energy gets used and by who and where, could be something that is then input into that original process. So maybe the architect's design that is incredibly energy efficient and produced in a factory setting to the utmost quality control ends up being the case that turns out, for whatever reason, our modeling was wrong. And the data we've collected in the 10 years since this building has come online has showed that all of the rooms on the west side of the building use substantially less energy than we predicted and less energy than the other sides of the building. And so that feeds back into, okay, how do we change the units on the west sides of our buildings? Maybe it's more window sizing or less window sizing to make sure more sun gets in or less sun gets in, depending on the climate. And that's a feedback loop that has never really existed. Architects do not get involved in the projects after they design them and after they are constructed. And so the framing of a building as a data source is a huge one. I think I don't touch on it directly because it's also a scary one. People thus far that I've talked to aren't super excited about the idea that every appliance they have in their kitchen is being tracked in how much energy it uses and when. I think it's safe to say there are ways that data transaction can happen anonymously and to the benefit of the user and the building designer and the facility operator. But as of now, the primary constraint around that specific use of buildings is really just a privacy one. But you're absolutely right in terms of the amount of detail we could get that is interesting and insightful on how people use buildings is not a feedback loop that has really ever existed. But it's for that reason an extremely valuable one for users, for utility managers, for designers, all of the above.
It's amazing. Marcus, I'm sure you have a lot of questions.
Well, I've got about 3.5 million, but it's going to try and condense it down.
Same.
So I love this, Tyler. Just to put you in the picture, I've been sort of trying to do this for many years.
Mm-hmm.
Two things which have immediately come to mind. So, yeah, having an integrated way. So I used to be a developer. Developers tend to work on how much does it cost? How much can I rent it for? And then how much can I sell it for? Because I'm selling the income stream. What they can't do is to look at what's the total occupancy cost. And so therefore the purchaser of the building, the renter, knows what the headline rent is, but doesn't then know what all the other costs will be. And there's a great resistance to sharing anything, even building information management systems. We have BIM, building information systems, which is componentizing it. People are very reticent about sharing trade secrets. But really what I wanted to do is to say, I had a wonderful discussion with an architect once, many years ago, very eminent architect, globally recognized. The name is a household name. I said, Marcus, you're destroying the mystique of architecture by talking like this. Because they're quite comfortable with the linearity. I'm the architect, you're the engineer. I design it, you just make it work. And you're the builder, you just build the thing. I'm the architect, you know? And I think there's a hierarchy. There's a perceived hierarchy. So I love what you're saying. I thought you did a really great exposition, but I didn't realize that the US was slightly less advanced than I had hoped. So I can introduce you to some guys. We're creating 17-story high schools in Australia, and my friends at Kajima are still advanced on earthquake-proof buildings and Archimedes bridges and all sorts of stuff. They've got wonderful systems. I can introduce you to some of the main board there if that would be of use.
Sure. Yeah. I think, I'm similarly disappointed that the US is late to the game. But I will say one advantage to that fact of there being so many successful proven models in other countries is that they tend to be pretty simple and straightforward in the other countries because they have a proven model and there's not a lot of innovation even within the industrialized construction space. But a huge part of why there has been, wrong direction, so much investment in the US currently is that there's a ton of different ideas. Even just the 3 layers that I present as potentially oversimplifications, man, I need to remember which slides go where. The 3 ideas I present in the like different ways that industrialized construction can be done, from huge modules being built in one piece to the Legos analogy, all of those, or I should not say all, most of those have come out just in the last 5 years or so from the US. And so an advantage to us coming late to the game and having a ton of new ideas all at once is that suddenly there's a way more diverse competition for what strategies or methods can exist and succeed. And I think one of the rare and beautiful advantages of the system of capitalism we do have is that there is a variety of competition, especially early on in an industry trend or emerging trend. And so in this space in particular, I think the digital age and the young adoption of these strategies in the US has led to a way wider variety of strategies that I think are producing way more interesting insights than the countries that have done this for years in one of the ways I presented, but needed to innovate beyond that.
I'm not gonna argue, but I think you'd be surprised.
Indra, can I just give Indra a voice?
Yeah.
I know that this is a meeting she's been
I was
waiting for.
Nikki, I was moving to introduce Indra into
Yes, for me it's most interesting speech, and of course I wrote down some questions for Tyler. So first question is it possible that digitalization in construction is still in such position because of possibilities to earn dirty money? So maybe we need to talk not about the digitalization, but about the transparency of market. Because, you know, as they know, there are some tools in construction area which can count every bolt, and you just need to use it. And maybe that we don't see the bigger picture.
Yeah. In short, there's a lot of different reasons why I think they've not digitalized. From cultural to organizational stubbornness to, I don't think it's a technological limitation, to be fair. I think there are plenty of ways in which very interesting insights can be gathered from a lot of different aspects of construction and design that we just aren't taking advantage of. And yeah, there's a colorful diversity of reasons why that is the case, but you're right in that we're not unable to, it's just been resistant.
And also, what the biggest challenge do you see the digitalization of construction? Because, you know, we need, I think, some kind of standard which can be used in all the world, that we see all the models with the tool which we have on our computer. So maybe the problem is also not the tools, but the standards which can be used all the programs. And also with this automated design, the same design can be realized with different materials. And how you imagine that it will reach comfort environment for people who use this building? Because of course, as you know, it depends also on the place where you built it. For example, at your hometown is this one environment, at my hometown is completely different.
Yeah, fantastic questions. The easiest answer and the very brief answer is I'm happy to not know most of the answers. The convenience of studying it and researching it is I depend on other people to have answers. But the insight I can give is that I think you're spot on about it being different in how you do design and what materials you use depending on location. And that can be, hypothetically, I haven't seen this done successfully yet, but that can be one of the things you choose in, for example, a potential design software tool. It can be a drop down and say you want wood-based or steel-based, and that will change where you get it from, how much it will cost, the highest potential that the building can be built to, and a lot of other factors. The research I've most recently done over the summer, last summer, was specifically trying to assess if the lifetime carbon emissions of a building could be one of the outputs that is measured and assessed in the initial phase of a building design. So not only the cost and the time required, or just the 3D space that it takes up, but if, depending on the material that's chosen and the energy efficiency goal that is aimed for, if you can actually have an expectation roughly of what the carbon emission impact will be of a building in the embodied materials used for construction, but also the energy usage throughout the life cycle. And I can at the least say people are interested in these questions and are considering it. I've not seen it done yet, but these are partial ways to address a lot of the really good points you just brought up.
Tyler,
But
thank you so much. We have to cut. Andreas is already with us.
Yeah.